Take a look at what we have here. Two objects that I can start at the top of a ramp. Both of them are going to roll to the bottom, but there's a slight difference in these two. One of them has a solid cylinder, and the other one has two weights. Now with the two weights, I can move them in close to the center and thereby reducing the rotational inertia of this compound object, or I can have the weights farther out with a larger rotational inertia. So let's make a race out of these two objects and see which one gets to the bottom of the ramp first. First attempt, we'll put the weights near the center, and you make a prediction which one's going to reach the bottom first. Ready, set, go. Very nearly equal for the two of them. Now, if I increase the rotational inertia of this one, we should notice a difference. Okay, make your prediction. Ready, set, go. You notice this one lags behind a little bit now that its rotational inertia increased, and the simple explanation for that goes something like this. The object has gravitational potential energy to fuel its motion down the incline, and so it gains velocity at a loss of height. But it's also gaining angular velocity as it rolls down. So if a larger percentage of its initial gravitational potential energy has to be spent on the relatively greater rotational kinetic energy that results by having a larger rotational inertia, then less of the potential energy it started with remains to provide its translation down the incline. A similar demonstration would be to rotate a hollow cylinder and a solid cylinder. Now in this case, we've made them of the same radius so as to eliminate that variable that you might think would factor into why one would go faster than the other. So with the cylinder that's solid, its weight is distributed from the center toward the outside, whereas the hollowed out cylinder, all of the weight is on the perimeter. So this has a relatively higher rotational inertia compared to its mass than this one's rotational inertia compared to its mass. So when I let the two go, make a prediction. Yeah, absolutely. This one is going to take more time to get to the bottom of the ramp because less of the energy, fractionally speaking, is spent on translation and more of it is spent on rotation.